Well, I'll start. What was this building before?
This I'll take that. So this is basically what it always was. It was always a sort of a row house residential two-family building. It's a wood frame, which is not that common in New York City, but we have renovated it to the Passive House standard. So a lot of people know what that is, but I'll just give a really brief overview. Essentially, we're doing really good insulation, air sealing, good windows, good mechanicals, and we're bringing our energy use down by 60 to 90%, depending on what you're comparing it to. I mean, it's a really steep energy reduction. We are providing a really quiet and comfortable place to live and healthy place to live. This is, as I was saying, this is set up as two-family. There's a one unit below that's occupied right now, and this is a triplex that's going to be occupied soonish by Alan, the owner. He's reading silly names.
Okay, well, what was some of the surprises with this particular project? I'll give that up to you, Paul, first.
Surprises. Working with Alan and meeting Alan again after a few years was a great surprise. It's just working with this old row house was just amazing. It's just an old, worn down wood frame construction, which is kind of beautiful. Not that common, but part of the city, and just to see what you can do with it. And there isn't much of the old house. The old house was quite worn. Not much left. We did save the floor joists, and the floor joists we saved, we probably sistered every one of them. And a few studs in the front and back wall. This is a nice project that Grayson is the project architect, and worked closely with Alan with the design and selecting materials. David selecting the mechanical systems.
Early from the first stage, and that's
what's
really
important
good.
is working with David from day one to just have a general overview of where the systems, what we need to do, what the insulation is. David did some beautiful calculations, and because we have adiabatic walls on each side, we didn't need a tremendous amount of insulation, and it's just doing a row house with all the warm walls against us. It's not an impossible task. It's easy. It's a no-brainer.
Just to put in context what it means when we're reducing the energy by the amount that we are, we have planned a 7.5 kilowatt solar system, which is maybe 2/3 or half of the roof, and that is penciled out, and you never know really exactly how these things will work out, penciled out to offset all the energy of his apartment, so the owner's apartment. So what we're talking about in this context is you go Passive House, you're putting yourself at the door of zero energy, which is where I want to be, and I think where as a culture we want to be as far as for the future, for our kids' future, and just financially it's very practical.
Yeah, just to follow up on that, by reducing our energy by 70-90% for a building like this, it's probably 70% over our current code buildings and 90% over your standard leaky row houses. But by reducing that energy, then you'll only need a small amount of energy to put a solar system on. And the solar system pretty much pays for itself in 3 to 5 years, 3 to 6 years. There's a series of grants and tax credits that are available. There's a few good companies. The company that gave us the original bid for here is no longer around, but there's another company, Clifton Residence, that we started to work with. Mm-hmm. We should get your revised proposal for this.
Mm-hmm. Interesting way to find that out.
I've been meaning to call you.
But another part of this project, which I think probably my favorite part, is actually all the wood. And there's a brochure in the front. You sort of can walk through, and there's a story to how reclaimed wood was used in the building. But it'd be cool if you just said a few things about maybe the facade or some of the floors and how things came together.
Yeah, I guess a couple aspects to it. It's certainly interesting and great to apply these woods here and try to feel out how they found their place. There was no right answer, but each kind of floor has comes from maybe a different region of the country, so it tells a little bit of the story about the old growth forests of the country, and it needed to kind of fit into the aesthetic and the performance of it and so forth, but it mostly fell into that storyline. The other part of it was just the connection of the woods to Passive House, and I really, it makes sense that reclaimed wood and Passive House are kind of complement each other. They both have this sustainability quality to them, but they're very, very different. One is something that's always present but invisible, and the other is always present but very visible. And it was interesting to see how those two kind of came together in the project. And I got into Passive House by seeing some customers that were incorporating the woods into their passive houses and got interested into it. And then I saw a grainy video of David White in the backyard. Some
Public access television.
Yeah. And got in touch with him, and he pointed me to Paul's firm, and then I recall meeting Paul about 15 years ago at a building that he was working on in the East Village. At the time, I think catching rainwater was the big environmental push, so it's come a long way since then. But it's been a real pleasure to kind of get into this and to see it kind of close.
Can you just talk really quickly about the front and back facade and what they are
Okay.
and what
Yeah, so
where the wood comes from?
the front is this Shosugiban process that we use Douglas fir from wood staves from Worcestershire sauce tanks. And it's a neat thing to use, but it's actually very practical wood. It's already has exterior performance quality, and it takes the Shosugiban well, and it's very clear without knots. So aesthetically, it's just a beautiful material. We kept the original proportions of the facade and the clapboard, and there are just some kind of minor tweaks to it.
And Shosugiban is?
It's if you're familiar, it's the charring of the wood. You burn the wood. We did in the backyard. Shh. And
Your fire department permit is where?
we had a barbecue going at the same time. But it actually was very safe. We did it with a roofing torch. And then the rear facade is boardwalk, which is an interesting material, but it's very durable.
Coney Island boardwalk.
Yep.
David, maybe you want to talk a little bit about the mechanical systems and
Yeah.
briefly explain energy recovery ventilation?
Yeah, so one of the things that is, what's the word, conventional wisdom is that if you want to make a building better, then you have to spend more money on it. And the way that we answer that with Passive House or with any high performance building is that we use the higher levels of insulation and air sealing as a way to enable smaller, simpler, less expensive mechanical systems. And small is automatically less expensive when you're in New York City because space is so expensive. So the heating system for this building has a total capacity of about 42,000 BTUs, but in the coldest winter day, it has a total capacity of 27,000 BTUs. Compare that to the 175,000 BTU boiler next door. And so when we make a system that small, you can install an air conditioning system that is powerful enough to heat the building when it reverses in the wintertime. So these are all just Mitsubishi mini split heat pumps. There's one ducted unit on each floor. One unit is right there. That's the supply grill over the entrance to the bathroom. And then there's one on each of the other 3 floors. The house is very airtight, so we want to ensure that there's enough fresh air all the time. And when you bring in fresh air, you have to heat it up in the wintertime and cool it down in the summer. So we use what's called a heat recovery ventilator. So there's a heat exchanger in the middle of this box, and it brings cold air in from the outside, and it brings warm air out from the bathrooms, and they go through this core through dozens of little passageways. And one passageway is the bath, the other passageway is the outdoor air, and they just alternate, and they exchange heat across the walls of that core, so that by the time the outdoor air gets in, it's most of the way to room temperature, and it's comfortable, and you've recovered all that energy. And it does similar things with humidity if you have the right kind of exchanger. That's called an energy recovery ventilator. And so that's how we get fresh air to the entire building. That's about it for the mechanical systems, right?
What do we got set up here? You want to talk about this a little bit?
Oh,
Yep.
This is a blower door. So when we want to make the building airtight so that we don't have outdoor air coming in and use lots of energy to heat up that air. Interestingly enough, the air inside this house will actually be cleaner than the outdoor air. So one of the biggest, most sort of health impacting pollutants is ultrafine particulate matter that comes from combustion, both from cook stoves and cars and trucks outside. So if you bring the air in through a duct and you filter it, you can actually eliminate that particulate matter. So this is a blower door. So during design, we all work together to make the building as airtight as possible. And then during construction, nothing is ever entirely perfect. So what you do is you put this in. This fan blows air out of the house and puts the house under a little bit of suction. And then air starts leaking in through all the cracks. And we go around with a little stick that makes smoke, or sometimes an infrared camera, or just put some water on your hand and sort of feel around. And that allows us to find the cracks, then we seal the cracks. And this door is really useful because it has a sensor inside the fan that measures how much air it's able to move. And this gauge is also measuring how strongly the fan is depressurizing or pressurizing the building. So if we know how hard it's pushing and we know how much air is moving, then we know in a sort of standardized way how leaky the construction is. And the Passive House standard has a very stringent value for how tight the building has to be. And just last week we passed that standard, so we're happy about this.
Good work.
Typically, a blower door has a fan that's about 2.5 times the diameter of this fan, and that fan was not big enough to depressurize this house when we started. This fan is actually used for testing duct systems, but it was about 5 times larger than it needed to be when we got finished with the project. Are there any more questions?
What are the critical benchmarks in terms of just your quality control process? Working with the architect, like, how many are there? Like 4 or 5? Like which?
So
What does that mean?
Yeah, so I think you're asking for certification of a passive house. What are the benchmarks?
When he's in construction and you guys are doing these things.
So
Sort of milestones?
Yeah, milestones for you to come in here and
Yeah.
to assess what the contractor has been doing.
Right.
What are some of the critical ones that?
The hardest is the air tightness, because you want to be able to assess it when you have enough of it built that you can seal it off, but none of it is covered. So our air barrier for this project consisted of membranes that are behind the finished materials, so we had to not do any drywalling until after we'd made sure that that particular area was airtight. And the air tightening testing goes in stages. You do one early stage as early as you can, get the thing sealed up, a sort of final stage when the air barrier is complete, and then a third stage when the entire construction is complete, just to make sure nothing was broken.
So what's good about that is before you put all the gypsum board on, you can tell if you're meeting the criteria, and you have an opportunity to make little repairs and to find out where there's little mistakes. rather than coming at the end of the job and finding out that it's not working. So you can always take this air test. It's a bit of an effort for the workmen to do all the taping and meet the criteria, but you have the opportunity to get it up to passive house standard during construction because before you close all the walls. You doing that test is critical.
Do we have any other questions?
What about the lighting systems? Did you do any like electrical energy saving strategies?
We try to specify energy efficient lighting. So part of the passive house standard is hitting an energy demand, which your lighting and your equipment is all part of. So the equipment is all, so like refrigerators and things are all energy efficient, and then lighting for the most part is very energy efficient, but you can have, as long as you're within the standard, you can have a chandelier or two that sort of goes beyond what we would call energy efficient lighting. But typically, yeah, you have to have energy efficient appliances, lighting, sort of everything in the house needs to be working towards bringing energy down. But because it is a performance standard, you can have something that's a little high and offset it somewhere else.
Are most of these light fixtures LED bulbs in them?
Yeah.
I think
So you're
like 90% probably.
90% are still
There's
LED
a
bulbs.
little wood from the Edison factory
Just bulbs.
downstairs.
From West Orange, New
What?
Jersey.
Yeah. That's his contribution.
And the quality of light is great. Is greatly improved with LEDs, and you can see the quality.
Yeah.
Nice warm.
Yeah, a lot of times the screw-in LEDs that I see are better quality than the LED fixtures that you buy with the lamp built in. You want to look out for flicker, so just go near the lamp and get a dark surface and go like this with your finger. If you see a lot of fingers, it's flickering and it's driving you crazy, although you may not know it. And also look at color quality. So if it has a high color rendering index and it has a high red output, R9 is the index they use, that's a high quality lamp. And you pay a little extra, it uses a little more energy, but it's still a fraction as much as a regular bulb.
But yeah, I think for the most part, anybody's plugs at home, you can take a LED from Home Depot and screw it in, and it's going to work. If you have it on dimmers, you might want to be careful.
Yeah.
They sometimes don't work that well with dimmers, but
The IKEA lamps are quite good.
And the larger passive house windows, so a lot of times you're not putting on the lights.
yeah.
Okay, final takeaway. What if I don't own a home, but I'm really interested in all this? What can you suggest to someone like me to save more energy?
Rent in a passive house. There's not enough of them. LED bulbs.
Yeah.
It's a big, you're going from 100 watt bulbs to, 6 to 10 watts.
Turn off your computer.
Turn everything off.
Turn off your, what is
TV.
it? Your TV control.
Yeah,
Wi-Fi,
cable box.
Cable box.
We have
Quite an efficient one.
Yeah, we have two different passive house standards in the U.S. We have the German Passive House Standard, and we have the Passive House Institute U.S., which has its own standard. And when they went off on their own, they wanted to tailor passive house to the U.S., so they started looking at data for how much heat is generated inside of American homes. And that depends on our bodies and also on lights and appliances and all the other stuff we plug in. And compared to the Germans, the numbers that you assume when you're working with the Passive House Institute US are way, way, way higher, because Germans understand that if you turn it off, it stops using energy. In the US, we don't have that same habit. So get into the habit. Somebody worked very hard to put the light switch near the entrance and exit of the room so that you can just go like this. And that's all the work you have to do.
They didn't work that
It makes a
hard.
tremendous difference. In my building, there are 8 identical apartments, and the electrical use varies by a ratio of 7 to 1.
Wow.
Well,
It's all about behavior.
About sustainability awareness, do you believe that sustainability awareness is growing exponentially, or it's like pretty slow and compared to other countries? Because I know that in Germany it's been happening for a long time, but here in the US it's taken a lot of time to approach to sustainable design.
I think it's both. I mean, I think passive house is growing, if not exponentially, passive house is exploding in the U.S.
Yeah.
And we're also really far behind Germany and really far behind UK. And there's a lot of room to grow.
So this channel measures the difference in pressure between these two ports and this one between these two ports. And this one's measuring, this one has no hose on it, so it's measuring inside the building. And this one is measuring outside the building. So it's telling us how much pressure difference there is between inside and outside.
What does it read now?
I don't know.
Oh, okay. Still.
It's kind of zero because the doors and windows are open still. This one measures pressure inside the fan at a gauge inside the fan. And so based on that pressure relative to the inside, it'll calculate the airflow through the fan. So the way we're going to configure it is, you see how it says 50 here? So we're going to tell it, push as hard as you have to get this to read 50. Okay, 50 pascals means I take a tube, a U-shaped tube with some water in the bottom, and I blow on it until one side is 1/5 of an inch higher than the other side. That's how much pressure it is. It's not a lot, but it adds up. So it's about, over a square foot, it's about 1 pound of force per square foot. Okay. Can somebody close that front door?
So what's the magic number? The limit that you have to hit?
We were doing the Passive House retrofit standard. So it's, when you pressurize it to 50 pascals, you're allowed to have one air change, which means you leak the volume of the building once every hour, one air change per hour. And the volume is calculated, of course, in a very labor-intensive way since it's a German standard. So you take out the walls and you take out the stairwells and the dust bunnies and all those things, and you get this like net volume. In the US, the volume is just the outside. That's easier. All right.
We're open again, David. Hold on one minute.
So at a couple minutes ago, you might have seen this go down to around 400, 500. The target is 350, and we got just below that last week, so it passed. So it's 350 cubic feet per minute at that pressure. And when we first started, it was around 7,000.
Wow.
Which is more like a normal house?
More like a normal house, yeah.
So obviously they kept opening and closing the door during that, so the fan was going.
Yeah, that's why it gets...
But if someone opened a window on the top floor, would the fan still...
Yeah, for that, I mean, to run the test, yeah, we have to... And yes, if they open that up there, then that pressure will will propagate down.
Yeah. And what are these ventilation forms that you seal up?
So when we do the test, we're allowed to temporarily seal the 2 ducts that go to the outside for fresh air.
We saw that on the 4th floor,
Yeah.
in that closet with all the mechanical systems.
What'd you get? What was the number?
It went down to like 500. But we
All
didn't-
right, well, thank you, everybody. Thank you, David. Thank you.